Hi everybody, this is Tim Urdan, author of Statistics in Plain English, and in this video I am going to show you how to perform an independent t-test in R. If you're familiar with R already, then this should be pretty easy to follow. If you're not familiar with R, you might want to take a look at my earlier video called R, Descriptive Statistics and Overview, to get a little bit more of a sense of how R works. There's other videos also on YouTube or online that will give you an overview of how R works and how the R Studio is set up. But basically, up here in the top left corner is where your code is, where your commands are. And then down here in the bottom left corner is where the output of your runs will be. Over here in the top right corner is where your list of data sets are and some of the characteristics of the data sets. And then there's various things down here in the bottom right corner. Right now I've got it on files that show different files in my computer's directory, but there's other things here. Help is particularly useful. So let's get to the independent samples t-test. Over here, these first couple of lines that are in green with the hashtags, those just are notes to yourself or to other people using your code about what you're about to run. So the first line of actual code to run is this summary data for Wave 3 English grade. This is the grade students received in Wave 3 of data collection. So this is the fall quarter when students in my sample were either in the 10th grade or the 12th grade. And the group variables are gender. So I'm going to compare males and females on their English grade, their grade in their English class. So let's run that. And this is not the t-test, this is just the summary statistics. So this gives you descriptive data by group on the dependent variable. So we can see we've got males and females, and there's 326 cases in the male group, 338 in the female group, so pretty similar. And then these are extra cases that were not we didn't have data for on gender. So the mean for males is 7.159. The mean for females is 8.381. And just looking at these different means, it looks like in these two samples, females have a higher average grade in English than males do. Here's the standard deviation for males, standard deviation for females. You can see those standard deviations are very, very similar. So that tells you that we probably have equality of variances, which is an important assumption to test in an independent t-test. Standard errors are also very similar. And then CI, which I believe is the confidence interval, the range of the confidence interval for the mean for the male sample here and for the female sample here. Okay. Next, we're going to run the Levitin test. This is the test for homogeneity of variance. That's this line right here. So we'll run that. And the p-value here, if that is smaller than 0.05, that tells you the variances are not equal between the two groups, and you have to adjust your degrees of freedom when you're looking at your t-value. But here our p-value is greater than 0.05, so that tells us the variances are equal. And we can use a regular pooled variance. We also see the degrees of freedom of 662 for the error and 1 for between groups. There's two groups, so the degrees of freedom between groups is number of groups minus 1, which gives us 1. And then 662 is the total number of cases minus the number of groups. So That means there's 664 cases in this data set, and the degrees of freedom would be 664 minus 2 is 662. And we can look up here and see if we add the n for males with the n for females, well, we do in fact get 664. So now that we have tested whether the variances are equal, we can go ahead and run the t-test, which is this line right here. And we're telling R to run a t-test comparing the two different gender groups on wave 3 English grade. And when we do that, we get this data down here. The t-value is negative 4.462. That tells us that the mean for the first group, which was males, is lower than the mean for the second group, which is females. That's why we have a negative t-value. Degrees of freedom, again, is 662. And the p-value is 9.516 to the negative 6th power. So we're going to move this decimal point here 6 places to the left, be 0.00009, which is much smaller than 0.05, and that tells us our difference between the sample means is statistically significant. Did not occur by chance. That R then says, so because your result is statistically significant, you need to reject the null hypothesis and accept the alternative that there's a true difference between the means of males and females, that the population means of males and females on wave 3 English grade is not equal to 0. This is a 95% confidence interval for the difference between the means. You can see both those values are negative, so in the confidence interval, the difference between the population means shows that females have a higher mean than males. And these are the sample estimates for the means for males and the means for females. So now we know that the t-test is statistically significant. On average in the population, females have a higher mean on English grade than males. And now let's run a effect size analysis. So we're going to bring in the library to run that. And we're going to bring in the effect size library. And now we're going to run a Cohen's D. And we get this output down here. So our Cohen's D is negative 0.35. It's negative because, again, it's the male sample mean minus the female sample mean. And that produces a negative number because the female mean is higher. And we take the absolute value of that Cohen's D of negative 0.35 and say that the effect size is 0.35, which is considered a moderate effect size with some practical significance. And here is the confidence interval, 95% confidence interval for the effect size. So that's how you run independent sample t-test and a effect size, a Cohen's D effect size.